In this video from IT Free Training, I will look at the terminology and components that are used with IP4. Having an understanding of these concepts is essential as it forms the building blocks of modern networks. To start with, I will look at what is an IP address. An IP address is simply a unique identifier for devices on a network. To give a common real-world example of this, consider a telephone. Every telephone has a unique number assigned to it. Since a phone has a unique number, it allows anyone that has that number to call that phone. Just like a phone, each device on a network can be given a unique number called an IP address. If you want to contact a device on the network or the internet, you only need to know the IP address of the device. Let's have a closer look at an IP address. An IP address, well, in this case a version 4 IP address, is 32 bits long. If you were to look at it as a 32-bit binary string, it would be difficult to make sense of. For this reason, a 32-bit address is divided up into 4 parts called octets. If you look at this in binary, it is still hard to read. For this reason, IP version 4 addresses are often written in dot decimal notation. As you can see, IP addresses are a lot easier to read and use in this format. If this format is so easy to read, the question to be asked would be, why would you worry about looking at it in binary? This brings us to the next topic of the subnet mask. A subnet mask divides an IP address into networks and hosts. On the left-hand side are always ones, and on the right-hand side are always zeros. There are 2 ways subnet masks are represented. The first way is using dot decimal notation, the same way an IP address is written. The second method is slash followed by the number of 1 bits that are used in the subnet mask. In a later video, I cover subnetting in more detail, but essentially what happens is that the fewer 1 bits that are used in the subnet mask, the fewer networks that can be created. However, fewer networks means more hosts or devices can be placed on that network. The opposite holds true if you increase the number of 1 bits that are used in the subnet mask. When this occurs, more networks can be created, however each network supports fewer hosts. Particular subnet masks are easier to use than other subnet masks. However, you can see that depending on what your organization's needs are for devices they require on each network, may mean that decision of which subnet mask to use is made for you. The next point to consider is how the subnet mask is used in IP networking. The subnet mask is used in your device's basic routing to determine if network traffic is for the local or remote network. Let's consider that you have a computer that is connected to a network, and on that network is also a server and a router all connected to the same network switch. Adding to this, there is also a server on the remote network connected to the router. The question is, how does traffic get around the network? The first step is to assign each device an IP address. Once the IP address has been assigned, decisions can be made where to send traffic to ensure that it gets to its destination. This is because the left part of the IP address is the network and the right part is the host. If the desktop wants to send network traffic to a device on the same network, it will send it directly to the device. If it wants to send it to a remote network, it will send it to the local router, which is referred to as the gateway. Question is, how does it make the decision where to send the data to? To do this, it makes use of the AND operator. The AND operator is a mathematical calculation that works at the binary level. When the AND operator is applied to bits, it gives the same result as multiplying them together. To understand how this works, consider this table. The AND operator takes 2 bits, looks at their values in order to get a result. If I consider the first case, if the first bit and second bit are both 1, the result will be 1. This is the same result as multiplying bit 1 and bit 2 together. 1 times 1 gives 1. If I consider the next case, the first bit is 1 and the second bit is 0. This gives a result of 0. If you were to multiply 1 and 0, this would give 0. The next case is that the first bit is 0 and the second bit is 1, which, just like before, gives the result of 0. The last case is when both bits are 0. When this occurs, the result will be 0. So you can see that the AND operator is easy to remember. All you need to remember is that if both bits are 1, the result is 1. Otherwise, all other results are 0. The next question is, how is the AND operator used to route traffic? Any device on the network when sending traffic needs to make a decision if the traffic will be sent directly to the local network or to a router to get routed to its destination. Let's first consider how traffic would be routed if the destination was on the same network. Consider a computer on the network. In this example, it will communicate with a server on the same network. So, a computer will send data directly to the server. The next question is, how does the computer make a decision if the data should be sent locally or remotely via a router? To do this, the AND operator is used. To do this, a bitwise AND operation is performed between the source IP address and the subnet mask. The result of this will be recorded. Since the result is a long string of binary numbers, it is hard to tell what has happened. Essentially, what has happened is the network part of the IP address has been separated. This means that the network of the source computer has been calculated. The next step is to work out the network of the destination IP address. The same process is followed, and the AND operator is used with the destination IP address and the subnet mask. The result will give the network that the destination IP address is on. Now that the source network and destination have been found, they can be compared. In this case, both networks are the same, so this means that the source IP address and the destination IP address are on the same network. So the result is that the traffic will be sent directly to the server. Whenever the networks match, the traffic will be sent directly to the destination. Let's consider another example. If the same computer this time attempts to send data to a remote network, the following will happen. Like before, the source IP address and the subnet mask have the AND operator applied to them and the result recorded. The next step is to apply the AND operator on the destination IP address and the subnet mask and record that result. Notice, however, that when the results are compared, they do not match. The source network and the destination network are different. Only one bit is different, but that is enough. When this happens, the network traffic will be sent to the router. The local router on the network will be configured on the device as the gateway. This covers the basics of IP addresses, subnet masks, and routing. If it is still not clear, don't worry, because in later videos I go into these topics in more detail. I hope to see you in those videos. Until then, I would like to thank you for watching.